Oh, look at that. I'm there looking at myself. Welcome, people. Welcome to this talk on TypeScript. This is a special talk. Oh, look at that. I'm there looking at myself. Welcome. Yes, I had to mute myself. Now I learned that the hard way. Okay, so this is super special and weird setup. I don't see you, you see me. So we're gonna do something special to make it more interactive. So anytime you have any question, you just want to say hi, just put it on the chat, and I will go through the comments throughout the talk and interact with you. Awesome. So right now I can see that Andreas has said something. He says, looking forward to learning more about TypeScript. Yes, me too. So let's try it out. If you are now here, say hi, and I will say hi back. Andreas saying hi, I say hi. So anytime that you have a question or anything, just pop it out, even if you want to say hi, and I will, throughout the talk, I have placed animated GIF strategically, so I will know how to or when to look at the chat. Awesome. So I'm, I need to go into this screen now. So I'm Jamie, and I'm in space. I'm a software engineer in Google Stockholm. We have a really cool office here in Google in Stockholm. We do a lot of interesting stuff, particularly with communications. We do WebRTC, we do Google Meet and Google Duo, and we're always looking for more awesome colleagues. So if you're interested in it, you can go here, find your next job at Google. We have often open roles for software engineering, or also cloud engineering, customer engineering, even sales and marketing. So take a look. I think that right now we have a role, open position as a software engineer. I'm a front-end software engineer in Google Meet. So some things I've been working on are like the UI in Howard in meeting rooms. I've been working also on the web client. So the new landing page is something that my team and I have been working on. And I'm also working in the Meet Quality tool, which is a tool for admins. It gives them an idea of how their Meet is working in their organization, and it helps them troubleshoot it. I sometimes do talks. I do talk occasionally on meetups or conferences. I sometimes organize stuff as well. That's something I've been doing less and less, because now most of my time is spent with my son Theo. He's very cute and therefore demands my attention. I also like nerding around. So this is my blog, barbarianmeetscoding.com. I write about web dev stuff. This blog has the weirdest introduction to any blog on the internet. That's because blogs don't have introduction, but this one has one. These are some of my projects. I've been working on the JavaScript project, where I mix JavaScript and fantasy, and it's very fun way to learn JavaScript. I also have been doing boosting your coding food with VS Code and Vim, a way to make you more effective with VS Code by using Vim. There's a free online book that is available for you to read online. Just go to the blog, and there you have a link for the book. And my latest project is Wizards Use Vim, where I mix, again, Wizards and Vim. It's a project where I'm writing a book to help people learn Vim in a fun way. If you want to know where I'm normally around, I'm on Twitter, on Vintaras. That's where I normally hang out, and where you can reach out to me with questions or just telling me hi. Today we're going to talk about TypeScript. So the way that I like to sell TypeScript is that it's a modern and safer version of JavaScript. It's a superset of JavaScript that it includes, in a simple way, it's JavaScript plus the latest features plus some syntactic sugar plus types. And the way that we normally talk about TypeScript is that it's JavaScript that scales. All the things that you get from TypeScript helps you build large-scale applications. And the more important point there, the thing that lets you write these high-scale applications is types. The type system is what makes TypeScript TypeScript. It's what gives you that great developer experience, and it is what makes TypeScript work at scale. So some of those benefits are like that sub-second feedback, detailed error messages, smart completion, semantic code navigation, smart refactorings, automatic code fixes, and more. These are things that are very in your face, but there's also benefits to TypeScript like that are more subtle and nuanced, like the fact that it gives you an additional layer where you can convey more intention in your code. Okay, so the goal for this talk is that we're going to try to learn how to leverage the type system to be more awesome and write more maintainable applications in TypeScript with less effort. The gateway to the type system in TypeScript are these type annotations. So they are extra bit of information that help TypeScript understand your code. These are extra bits of info that improve your dev experience. For example, that super fast feedback when you do something dumb. That's like an easy way to explain TypeScript. So we have this function that adds a couple of things. We don't know where it is. We add some types. We now know that they are numbers. And if Jamie, who's crazy, tries to add 1 to a banana, the TypeScript compiler will say, banana? And then we get super angry. Banana? It is a string! And then it explodes. And then everyone dies. Yeah. But this happens at compile time, which is good because it will ensure that no bugs reach production. And we know that when something reaches production, it's a lot more expensive to fix than if you get this in your editor right away. So all these benefits that we've seen are what make TypeScript great at scale. An example of scale is how we use TypeScript at Google. So at Google, we have this one giant monorepo. And here is where we have everything. So we have all our products like Gmail, Calendar, Google Meet, Google Photos. But in addition to that, we also have our frameworks. So the frameworks that we use to build applications, they're also in the repo. Libraries, Angular, everything is that repo. And everybody's working on head. You're always working on the latest version. You write code in a change list. That's how like an atomic change that is interrelated. And then we run distributed builds with Blaze. So what happens is that whenever you are working on a project, you build everything from scratch. But then because there's different people around the world that also building the same things, we're using a cache to reduce their builds. And that way it gets pretty fast. Every CL is code review, and then we use continuous integration, continuous deployment informed by test. So this gives you an idea of how we work at Google at scale. So a good way to think about it is like thinking, okay, imagine that you're working on ASP.NET, Angular, and your own web application, and everything is in the same repo, and it's changing all the time and at the same time. So that's an idea of how a monorepo feels. And in this context, all the rich type information from TypeScript is really helpful at this scale. In fact, did you know that Google has been using typed JavaScript since 2004? Now you know if you didn't. And this was through Gmail. Gmail came out in 2004, and it came out with the need for technology that wasn't available at the time. In particular, the Closure compiler. So the Closure compiler is something that helps you optimize your code, and it uses types in order to do that optimization. So yeah, it uses exactly. It uses JavaScript code it optimizes JavaScript code through leveraging that type information. It does some type checking, but it's not designed for tooling. It's designed for optimization. That's its main goal. And that's why it isn't as good to provide a good developer experience. So if this is a function in TypeScript and you have the same add function with a couple of numbers, this is how we would type it in a closure-friendly way. So we use JSDoc, and there is where you are your type. So you can see that this method has two params, A and B, that are of type number, and we see that it has a return of also type number. And you can see that this is not as ergonomic, as developer-friendly as the TypeScript version. So working with JSDoc is a lot more cumbersome. You don't get the same developer experience, and you have to write a lot more code. So that's why we migrated to TypeScript. We're in the process of migrating to TypeScript because Google has a huge code base of JavaScript code. The Closure compiler is very rich in the sense that it understands a lot of different types, and they are very similar to what you have available in TypeScript. So TypeScript became an official Google language at Google in 2017, and there's been an effort to work with both TypeScript and by keeping interoperability with all the JavaScript code that we have at Google and the tools that we have to optimize it. So now today we combine TypeScript with the Clojure compiler, and TypeScript gives you a great developer experience whereas the Clojure compiler gives you a great user experience because it optimizes your code, reduces the payload that the users get, the pages are faster, and therefore you get a better user experience. There's a lot of things that we built to interop between these two different type systems, because as we migrate to TypeScript, you still want to be able to use the existing code base, right? You need to migrate. You cannot migrate everything like at once. You need to do it gradually. So we have a bunch of tools that we built. This is SQL. All of these tools have been open source, so you can Google for them, and you will find them. I think they are in GitHub. SQL is a TS to Clojure tool. Clats is Clojure to type definitions. Setse is a tool that extends the compiler with conformance checks. So basically, it gives you additional errors that are not available in the compiler. And all of this enables large-scale refactoring and migration. So this is super useful. If you're curious about how we use, hi Marcus, hope you're having a nice day. So if you're curious about how TypeScript works at Google, how we use it, how our setup looks like, this is how we do. We have a common style guide, and that's what we use. So we have code reviews are deeply embedded in the Google culture, and a nice way to have constructive code reviews is by having a common style guide that everybody uses. We also have a formatter that applies most of the code changes that you need to do. And then there's this process of readability, where you learn how to write idiomatic TypeScript by going through a review process. And when you get this readability, it means that you know how to write Google-style TypeScript. Then we have the same TS config for everybody. Everybody uses the same flags, which makes interoperability very easy and jump from project to project very easy. It also means that the TypeScript team can perform refactorings across the whole of Google. If they need to update to a new TypeScript version, they can do that because everybody uses the same. We have a bias for strictness. So strictness means that the stricter you are, the more help you get from the TypeScript compiler, and we have a bias towards that. The problem is that we have a huge legacy source code base that we need to take into account. So we incrementally increase strictness with that baggage and background. It is integrated with our built-in tool, Blaze. We use TC for linting, and we use Clown for formatting because that's what we use for formatting everywhere else in Google. Okay, so what makes TypeScript type systems so special? Let's find out, because this is the purpose of this talk. So these are some points that I think that are what make TypeScript special. So what most important thing is that it's super faithful to JavaScript. It supports all the different idioms and techniques that are available in JavaScript, and its dynamic nature. It's very expressive and comprehensive, very complete. It has this idea of gradual typing, where you can have both JavaScript and TypeScript in a code base and incrementally add more types. It's inferable, which means that it can infer your types and save you typing and work. And it's erasable so that it disappears at runtime and it doesn't impact runtime performance. All these are really good characteristics. TypeScript has a super rich type system, able to model extremely dynamic JavaScript. So this is like the summary, the key point. We're going to go now quickly through all these. This is like the type landscape of TypeScript. We're going to go through basic types, any, unknown, null, undefined, void, never, generics, and advanced types. These sort of things. And we're going to use all these to illustrate how the deep characteristics of the type system. The beginning may be a little bit basic if you're experienced with TypeScript. So we're going to go super fast in the beginning and then slower towards the end. But it's going to be fun, believe me. And this is when I look at the chat. I don't see anything new. Yes, Marcus saying hi. I want to say hi back. If you have any questions for the people that has just arrived, just say hi in the chat, ask questions in the chat. I will answer them throughout this talk. And now we shall continue. Okay, basic types. Basic types, okay. So number, Boolean, string, date. This is how you put a basic type annotation in TypeScript. So we have this, let my name string be Jamie. That string It's a type annotation that tells the type system that this is a string. But we don't really need to do it because we have type inference. The TypeScript compiler is smart enough to understand that that is a string, and it does that for you, so you don't need to do it. So this is, I have these learning points when I have the TS to the left. This is like learning point. So TypeScript is able to infer types from its content, so you don't always need to explicitly state the type of everything. You can think of TypeScript type inference as a helping friend, trying to save you time and make you more productive. And that's why it's smiling. Okay, so take advantage of this anytime you can. Yes, only type when you need to. Don't be redundant. And then we have, likewise, a number. The type inference is working. It's handsome, true, of course, I'm handsome. And then birth, we have a date. So what happens if we use const instead of let? What happens if instead of using let my name Jamie, I say const my name Jamie? And this is a question for the audience. Put it in the chat. What do you think the type is if I use const instead of let? And I'm looking at the chat. Don't be shy. Answer. I will give you 5 seconds. 5, 2, 1, 0. I'm counting like my son. Okay, there was nobody that was... Yeah, string. Good. Michael says a string. You could think so, right? You would think that it could be a string. Patrick also says that it's a string. Anybody else that wants to take a guess? What happens with the const? Jamie. Yes. Andreas is right. Boom. When you use const, the type of this my name variable becomes Jamie. Wow. Mind blown. You know, I used TypeScript for years, and I didn't know this up until like a couple of years ago. So const will constrain your types as much as it can. So in this case, if you use const for the previously designed variables, we will see that the type of this is 23, the type of this is true, the type of the date is still date because TypeScript can't constrain the type anymore. So what happens here is that you use const. Const is a one-time binding. The TypeScript compiler is smart enough to understand that you cannot change the type of this, and therefore it constrains it as much as it can to Jamie. This variable will never be anything else than Jamie, therefore its type is Jamie, the Jamie string. In the case of the date, because we can still change the date after it's been initialized, then the type is still date. So TypeScript will always use its information available and try to constrain types as much as it can. This is called type narrowing. And narrowing is a good thing because narrower types lead to more type safety and can be really useful. In fact, these types that we saw are called literal types. So they are actually types that you can use. So here I'm using, I'm creating a variable, and I'm using a literal type, Jamie, so that this variable can only ever be Jamie. If I try to change it to John, the compiler says, no way, because this has to be type Jamie. It's a literal type. So when is this useful? When is this useful? And this is an example from D3. D3 is a library that allows you to build visualizations in JavaScript or TypeScript. So you write TypeScript, and then it generates SVG for you. So here we have a way to use D3 to create, to select a rectangle and set the attributes of that rectangle in width and height to 100 and 200. And this is what you get in the screen. A common mistake would be to just misspell this. And when this happens, you get a runtime error. And then the code stops working silently, and it can be hard to spot. It can reach production. A way to solve this could be to create a helper function. So you could create a function height, and basically in that function, you set the right string, and people using this function will never run into that issue, but it's not very maintainable, right? You would need to create a function for everything. So what if we relied on the type system instead? We could rely on the type system and do something like this. We say, okay, the attribute can only ever be of type height. That means that now you can only assign height to it. And then we can combine that with union types. Union types allow you to do this, right? You can say this type, this is a union type, and now the attribute can either be one of these two other types. It can be height or it can be width. So union types allow you to combine types. And then we have these type aliases that basically is a nice way to reuse types. So we can create this type alias called attribute and say this can be either height or width. Yeah, so it's a very convenient way to create custom types, type aliases. And then if you combine all these three, type aliases plus unions plus literal types, we get a super light way to create enums only in the type world. And now we can use that in our function. So we can say that this D3 selection has a function attribute, and the first argument is going to be of type attribute. So now what happens is that at compile time, whenever somebody misspells that height, the type system is going to give you an error because it says that it's not that string that you created is not assignable to the other two literal strings because you can only ever use height or width. So how are literal types useful? They move errors from runtime to compile time, and they offer you a clean way to solve a problem, but this applies to all types. And this is another interesting thing about TypeScript. It unlocks a different way, an orthogonal dimension where you can solve problems. And I will call this the type dimension. Okay, so here we have, whenever you work with TypeScript, you have these two coexisting dimensions that sometimes intertwine, the type dimension and the value dimension. And here we have this statement where we create a variable. And then we have the type dimension, and it's everything there. And in the right, we have the values. This is what happens when you are running the code in the browser, or in the server. It could be in the server. But when TypeScript compiler builds your code, this is what will happen as a result. So in the world of types, we have the type attribute, we have the literal type height, we have the union type height and width. And in the world of values, we only have a string, the height string. At runtime, this is the only thing that is left. And this shows us a different feature of the TypeScript compiler and TypeScript and the TypeScript type system. And it is the fact that types in TypeScript are erasable. They are completely removed from your code during transpilation. So this has a corollary, which is that you can't use types to affect anything at runtime. Only values affect runtime. And this is another corollary, which is that types have no impact on runtime performance because you are removed. So that's things that are good to know. So you still need to type a lot, right? You have this attribute, and now we're gonna put all the possible attributes in an SVG. It's still a lot to type. There has to be a better way, right? And there is. Spoilers. You will learn about that later, because TypeScript can use introspection on types. Okay, so now we continue with some more basic types. If anybody joined now, know that you can ask questions anytime or say hi, and I will answer. I will answer. I will answer. Arrays, tuples, and objects. Okay, so arrays. This is how it look. This is how you type it. You use the number and the square brackets, or this alternative, the Google Style Guide only allows the first one. But this is inferred, so you don't need to type it. You just create it, and then it just works. We also have tuples, so it's a finite array. This is how you do it. You say, I have 2 items, and they're of type number. And the good thing about this is that if we try to index something outside of the tuple, you get a compiler error. This is a type that only exists in the type dimension. So when you, it doesn't affect performance when you actually transpile your code, which is very nice. You have this that gives you help during development, but it disappears at runtime. Then we have objects. We have a simple object position that is as an x, y, y, and this will be how you type it. Again, the TypeScript compiler is super smart. It can infer the type for this. If you try to access a property that is not in that object, the compiler will complain and say, Jamie, you're wrong. This offers maximum misspelling protection, and I misspelling. The compiler told me that. Boom, fixed. This is such a common error in JavaScript. If you use an alias instead of using the type literal, then the compiler it gives you a more helpful error message. So in that case, it tells you that property cucumber doesn't exist in this type, which is nicer to debug. So when TypeScript knows a lot about the types in your application, it can be super helpful when providing information about issues and errors. So the more effort that you put in types, the more reward you get out of it. Then we have intersection types, where the union types are like an OR for types. The intersections are like an AND. So imagine that we have this type dog, and a dog can bark. It has the method bark. Now we have another type that represents something that can be drawn. You have a brush, and you can draw something into a canvas. And then you can combine them, both of them, with this intersection type or intersection operator, and you create a drawable dog. How is this useful? You may wonder. So this is how it is. Intersection types allow us to model mixins and traits with types. These are patterns that are common in JavaScript, and the type system in TypeScript allows us to model it with intersection type. A mixin, if you're not familiar, is a reusable bit of functionality that can be applied to existing objects and classes. In this case, that can be drawn is a mixin. You create this type and this object or function that can apply a common functionality to many things within your application. And a brush, for instance, could be a character and a color if you're implementing a multi-user dungeon like we're going to do right now. In the world of types, you have a dog that can be drawn, combine them, and you get a drawable dog. You have a cat, combine it with the mixin, you get a drawable cat. You have a dragon, rah, combine it with the can be drawn mixin, and you get a drawable dragon. And then in the values, so this is only types, right? And now we're actually doing it in implementation, in code. We basically combine, we make the dog be drawn with a D letter and brown. The cat's going to be C and yellow. The dragon is going to be D and green. We put it in an array and we draw it on the canvas. And this is what we get as a result. Look at that. Behold the sunken temple of doom with mixins. Oh, Robert is saying, awesome. Thank you, Robert. Nice to see you. Marcus is saying, hey, I'm also laughing. This is very funny. Okay, so the whole point here is that this intersection type allows us to model mixin traits with types. It allows us to model prototypical inheritance in TypeScript. And it brings us to the point that the TypeScript type system is extremely faithful to JavaScript and is able to model the most wildly dynamic things that you can do with JavaScript, like, for instance, just merging objects with each other. So you are using TypeScript, you're able to leverage the strengths of TypeScript, the strengths of JavaScript without the weaknesses. And this is the moment for a commercial. If you want to learn more about mixins or object-oriented patterns in JavaScript or TypeScript, here's a book for you. What are you waiting for? Get it, human! You're going to scare them off with all the screaming. But I'm so excited. What can I do? Yay. Boom. The commercial is done. So all these two union and intersection operators are type operators. They let you compose types in TypeScript, and they can be very useful. And here we have a hot tip. Play with types in the TypeScript playground. So whenever you want to know something about types, the best way to do it is to just tinker. So open the playground or your editor and just play with types. It's a lot of fun, and you're going to learn a lot. So now we go into functions. Andreas is rolling over the floor laughing. Me too. Okay, now we went to functions, and we're how many time? 30 minutes in. Okay, fast. Functions are the most fundamental building block of JavaScript applications, and therefore TypeScript has great support for them. We have this function. Normally, we will type it in line like this. This is very common. We don't need to type the return time because it is inferred. The TypeScript compiler, again, is super smart, and it knows that when you add two numbers, the result can only be a number. We have support for optional default params. The TypeScript compiler is picky, so when you try to call a method with more arguments than the ones that it's defined, it's gonna complain. One way to allow for more or less arguments is to use optional types. In this case, we're saying that the user ID is optional. So you could either call this function log with user ID or without user ID. And here we're doing that, and then it works. And these are two equivalent. When we use an optional type, we can say that if we use the one on top, it's like a shorthand. So we say this could be either string or undefined. That's what it means to be optional. So you can either send it or not. And this is default. It's very similar to optional. In this case, we're assigning a default right away. From the perspective of the user, it's the same, but it is much better for type safety because you're dealing with that undefined right away, right then and there. Defaults are nicer than optional params. But sometimes you may need them anyway. Rest params, when you have a bunch of parameters, you type them as a string, and then you can just log that I ate a banana, and then I ate candy. But one thing that is more interesting is functions as values. Robert says, best commercial ever. Thank you. I've been working on that for a long time. Functions as values. So a function as a value. Here we have the function add. This is how we did when we typed it inline. But what is its type? What do you think is the type of this function? I will ask this to the audience, but it's a lot to type, so I will just put it. But if you do it super fast, I will. Okay. The type of this function is this. It's a function add, and it takes a number, and it takes two numbers and returns a number. You can type it inline, or you can type it separately. And this is very interesting. Yeah, I will explain why. When is this useful? When is it useful, like typing the function separately instead of inline? So it's helpful when you have many functions with the same type. In this case, we have an operation and between two numbers, and we declare the type and reuse it in a bunch of things. This is good because it saves you typing, and it's also good because it creates a contract that has to be fulfilled by all these different functions. Whenever you expose a function as an API, then you use functions as values, or also when using higher order functions. This is very common in functional programming. So in this case, a higher order function, if you're not accustomed to it, is a function that takes other functions as arguments or returns a function. For instance, we have this function that takes a function as an argument. Is a log maybe function. So it takes a predicate that says should log and a message. And if the predicate is true, then it logs the message. And this in here, this is how we type a function as a value and how it can be useful to implement high order functions. And here we're actually using it. We have attack, we're attacking the target and removing 10 HP hit points. And now if it's set, I'm logging that the target died horribly. So sad, so sad. And another that returns a function. Here we have a create logger, and it returns another function with a header. And you can see that it returns type logger. This is the fancy way to do it. The hipster people actually only use arrow functions. And this could be easier to read if you're accustomed to functional programming, but I think this is easier to see that you're returning a function. The type that it's returned here is logger. It's something that takes a string and it doesn't do anything. It doesn't return. It logs its side effect. But because TypeScript is, again, super smart, it can infer this type, so you don't need to type it yourself. And then when we use this, we can say we create a logger Jamie says, and Jamie says banana. Banana. Okay. This is how we're doing with time. Because I put a timer here. And now it doesn't work. Okay, so functions as values and functional programming are core aspects of JavaScript, and TypeScript provides great support for both. And one thing that you may have not noticed is that TypeScript also has contextual typing. So types flow from right to left, like in this case, we have the function types in the right, and it flows to the left. But here it flows from left to right. So TypeScript will do its best to obtain types from its context. And this is known as contextual typing. So the point of this is that it lessens the burden of how much you need to type, because you don't need to do it twice, right? Then we have the function overloading. Function overloading is a mechanism by which a function can have different type signatures. And these calls get forwarded to the matching type at runtime. And the point of this is that it gives you better developer experience with better tailored APIs. This is not supported in JavaScript, but it is supported in TypeScript through the type dimension. Here we have, we've been using shorthand for defining these types before, but this actually is longhand. It also works. You're defining a callable object here, a callable shape. And then when we use this, we can say that you have a function that takes two strings, but you can also say that you have another function, an overload, that takes a number. And then when you use it, you can say that you can log that you burn the squid, the message, or you can use an error code like the undercooked salmon error code. And this, for instance, is super useful in the document create element. Here we're taking a tag, we're using a literal type, and we are generating different types of objects. This is super helpful because the moment that you use canvas, you know the type system knows that it can only ever return a canvas element, which is very nice for developer experience, because when you're using that object, you get IntelliSense and compiler support. So from the API user, you get great UX. Again, here, I'm creating an element. It knows that it's an anchor element, so it knows that it has an href element. But if I try to do something that doesn't make sense, I get a compiler error. But you have to pay for that developer experience in the implementer's side, because you still need to implement the function. And the function implementing looks like this. So it's still JavaScript, so you cannot do like in C#. You still need to create one function that is going to handle all those different cases and support the functionality. This has an alternative syntax, so you can use this that I like more, or you can also use an alternative syntax, so you have a bunch of functions headers. So taking advantage of types, TypeScript can provide the appearance and great developer experience of function overloading, which is super nice. Then we have interfaces. They're the light way to define a reusable type. So this is how it looks. Here we have a person, a crazy person, has name, height, weight, and age. And the good thing is that they help you enforce the contract of a class, object, or function. So here we're implementing this interface. If we remove a variable, we no longer implement it, so we get an error. We can implement multiple interfaces, and they let you do polymorphism. So here we have an employee, a manager, both implement person, and therefore when we want to hack a person, we can use either a manager or an employee. But it's a special type of polymorphism. It's structural typing polymorphism. A structural typing is if there's something that defines TypeScript type system above all else is this, that it has a structural type system. A structural typing is the same, is like the fancy name for duck typing. So it says that if it walks like a duck, quacks like a duck, swims like a duck, then it is a duck. And what this means is that you don't need to implement an interface in order to use polymorphism. You only need a matching API. So in a nominal type system like C# or Java, if you have an interface IDUC and you have a class that implements that interface, you're a duck because you implement that specific interface. This function will only ever admit IDUC implementations and nothing else. In the structural types world, if we have an interface IDUC with a quack method, we have a duckling, just an object with a quack method. We have Jamie that can quack, quack, quack. Then I'm a duck because I have a quack method. And this function will admit anything in the universe that has that quack method. So that's the difference between nominal type system and a structural type system. This is another example of how TypeScript attempts to be as faithful as possible to JavaScript. So going back, TypeScript structural typing means that you don't need to explicitly implement an interface. And therefore, I can use just an object here, and I'm using a monkey. And this is a monkey that, because it has the same properties that the person interface expects, it just works. And here we have a monkey that is a person. We have 10 minutes left and lots of content to go. So feel free to ask questions anytime. I want to go for 5 minutes more, and then we will get a round of questions. If there's no questions, we continue to the end. So even though we can rely on a structural typing to just use an object, implementing an interface has helped to catch mistakes, because if you don't implement it correctly, you get an error. And if you update it sometime along the way, you also get an error. That is very helpful. And they are not only for objects or classes. You can also have an interface for a function because functions are callable objects. Here we have an interface that is also showing function overloading. Interfaces are super similar to type aliases. So we have this interface person, and then we have this type alias person. They are exactly the same, and you can use the alias as well to implement. So you can have a class, implement an interface or a type alias, both work. You can also compose them. So here we're composing two type aliases with the intersection operator. Here we're composing two interfaces by extending them in a different syntax, but the result is the same. So if they're so similar, what is the difference? The difference is that type aliases are less restricted. You can use a lot more crazy things with type aliases. Interface only supports shapes, support the shapes of objects. Sending interface is also safer. So if we try to do this, we have a print with a print number. We send it with fax that has a print with string content instead of number. We're going to get a compiler error. Another difference is that type aliases with the same name result in a compile time error, whereas interfaces with the same name are merged. This is a useful pattern for building extensible libraries. For instance, here we're extending an array with a new function called range. That's how you do it. And here we're extending Jasmine with a new matcher. Something like you can say certain DOM element has an attribute. This is how you could do it in TypeScript. You still need to have it in the value space. It's only for types. Classes. So TypeScript classes are both values and types. This is the special thing about classes in TypeScript. So you have the class submarine. On the left, you have the type, the class you're using as a type. So we have this, let's say this variable is a type submarine. And on the right, you have values. In this case, we're creating an object that will be available at runtime. So in types, we have submarine. We can use it for with type operators, and we can also use it as an argument, type of an argument to a function. On the values, we just have the value itself that we use at runtime, and we can also use it to check for types because it's actually a value. So that's one of the ways in which you can check for types. Normally, you would write on polymorphism, but if you need to check a type at runtime, this is how you could do it. You can take advantage of classes. In another way, they're pretty much like ES6 classes. So what is the difference? Instance properties, access modifiers, and read-only. Here we have an example of how we have these members. These things are coming to JavaScript eventually. Now we have support for private members in JavaScript. Yeah, these are super helpful. Property initializers, this is how you do it. You have this syntactic sugar in TypeScript to initialize, write in the constructor new members. You all know about this. I'm going to jump over it. Abstract classes, also different, only available in TypeScript. Something that is interesting that we can type this. So these parameters, the type of this is normally implicit 99% of the time, but JavaScript is super dynamic, and sometimes this is not this. What? Not a big fan of this. Sometimes in TypeScript, in JavaScript, we can change what this means. And TypeScript supports this feature. In this case, we have, again, D3 code to create a graph. That's the part on the top creates a graph like this. Then the part on the bottom just paints the first element to red. So we draw the rectangles, and then we get into this each function. By all laws, this inside this function should be a selection, but it's not because we change it at runtime to be the current elements. This is like a super dynamic thing in JavaScript, and TypeScript gives you support for it. So the way that you do it is that you say this is of this type. And that's how TypeScript gives you support for these params, which is, again, a super dynamic feature in JavaScript. They also protect you from errors. So if you have this function that expects this to be click counter and you extract it, if you use like this, it works. But if you extract it like this and then use it later, the compiler will tell you, yeah, I expect this to be counter, but because you have taken it away from the context of the object, it no longer is. The TypeScript compiler will catch these errors as well. And you can also return this, which is great for Fluent APIs. So if you have, in this case, we have a builder. It should return this, and then you can use this as a type. And this is helpful because it's polymorphic. So if you extend this class, you can always return this, and it will know at runtime which is the right type. And yeah, this is just another example how good TypeScript is at playing nice with JavaScript. Then we have enums. I'm going to jump over enums because they're not that interesting. So we're going to jump over them. There was a VM joke here. That was fun. I'm going to go directly to some more interesting stuff. Any. So when TypeScript doesn't know what any is or what type of something is, it will use any. So in this case, it says, oh, I have no idea what this type is, so it's going to be any. And then what happens is that the TypeScript compiler doesn't complain if you make a mistake. So this is not so good, right? It can be confusing. Isn't TypeScript supposed to help you with writing safer JavaScript? So this is a trade-off. It's a trade-off of TypeScript being faithful to JavaScript that we need to take into account. And it's something that makes TypeScript easy to adopt. And this is where we get any helps TypeScript coexist with JavaScript. And this is where we get into gradual typing. You can have a web application that is partly typed and partly untyped, and you can improve type definitions over time. And it's something that makes TypeScript very easy to adopt and improve over time. So relying on any can be a great way to start adopting TypeScript in an existing code base. But to get most out of the TypeScript, you need to be explicit with your types. So the more information that you give TypeScript, the stronger TypeScript becomes. Here we have TypeScript becoming super strong. So a recommendation is to opt into strict mode. Strict mode enables a bunch of flags that make the TypeScript compiler be more strict with your code and give you more complaints and nudges to improve the typing of your code. So it nudges you slowly towards type safety by giving you these errors, and this is a good thing. One example is no implicit any. So if we enable this, what happens is that whenever you find something that is not typed, TypeScript would assume that it's any, then it would implicitly set an any type. But in this case, you need to set the type, and then when you set the type, it stops complaining. You could also use any. So if you explicitly say this is going to be any, it's also legitimate. So the TypeScript compiler will know that, okay, you made a decision, I will trust you. And this becomes an escape hatch, which is dangerous. So a better way to represent this is that when you don't know the type of something, so you're typing your application, you either know what the type is or not, because it could be something that's outside of the type system. So you can use unknown instead. An unknown is exactly like any, but it's a type safer version, because in this case we have any, and we try to call a property. It doesn't happen. There's no problem. But if you try to do it with unknown, you get an error because the type system doesn't know anything about it because it's unknown. So you can't use this type until you assure the type system that this type has the right type. So the way that you do that is with type refinement. And we're running out of time. So if you have any questions, feel free to ask them right now, and I will be happy to answer. Then we have like 2 minutes left, lots of content to go. But feel free to ask any question. I'm looking at the chat now. I don't see any questions. I'm gonna go for 2 minutes more, and then we will finish this talk so you can enjoy the talk that is coming next. No questions? I continue. Type refinement. This is how you, so TypeScript has this flow-based type inference so that it refines the types as it evaluates your code. So here we have this string array or undefined, could be both. If we use this code that says if people exist, then at this point, it knows that inside this block, it can only ever be a string, and then gives you help. Outside of that block, it's widened to be, again, string or undefined. So using these capabilities of TypeScript, you can refine the type of unknown and access and use it in a type-safe way. There's a lot of different operators that that apply type refinement. So it's nice to know which ones there are. But normally they're very, it's whatever you would use in JavaScript, right? So we're going forward. And that's, oh, it's done. Okay, thank you very much. It was a lot more that I wanted to talk to you about, but I was too slow. Oh, no. Wrap up. Thank you, Andreas. So thank you very much for coming, everyone, for coming. I'm gonna create a series of these in YouTube so that if you want to learn more about the type system, you can go to YouTube, the channel Verbarium is Coding, and I will upload a lot of things more about the type system, like advanced types, mapped types, conditional types, infer. Yeah, so in the end, the TypeScript type system, I hope you've learned a lot, even though we didn't get to everything. The most important thing is that it's faithful to JavaScript. There's a bunch of things that you can think about when using TypeScript: rely on type inference, enable strict mode, get rid of nulls, dry your types, use unknown over any, understand type versus value, and take full advantage of TypeScript. And above all, have fun. Have fun. There's a question. Do you usually prefer type over interface or vice versa? I think it depends. I think I like type because it's so lightweight, but there's use cases where you can use either or. I think if it is something that is going to be extended by a class, normally I will use an interface. If it is something that needs to be more dynamic, like for instance a map type or conditional types or something that is slightly more complex, then I will use a type alias. And if it's something like super simple, or if it's something that you can only do with an alias, like union types, then I will use an alias. Thank you, Andreas. Thank you, Marcos. If there's any more questions, feel free to put them in the chat because I can always check this afterwards. Thank you and enjoy DevSum. Have a nice weekend. Catch you in the internets. Game is out. How do I stop this? Thank you everyone for coming. Well, I know how do I stop this? I don't know. Do I leave the meeting? Stop sharing. Stop sharing. Jamie slowly floats in space.